Welcome everybody to the part 3 of this video series on limits that I've been making. In this video we will be discussing the rationalization type questions. And with that, let's get started. I've taken these questions from the Maharashtra government textbook, Maths Part 2, 11 Standard, Exercise 9.3. Okay, so let's begin with the first one. Like I said, all we need to do is rationalize this. So we are going to have root over 6 plus x square minus root 6 upon x, and multiply that with root over 6 plus x square plus root 6, the whole divided by the same expression. So when you do that, the numerator is becoming of the type a minus b into a plus b. So the numerator can be written as a square minus b square. And when you write the numerator as a square minus b square, that becomes this minus root 6 square, which will be equal to 6 only. If you open up the bracket, you have 6 minus 6 getting cancelled, and from the remaining two terms you can pull out an x common. So you will have x into 1 plus x, nothing else left in the numerator, and in the denominator this x will get cancelled with the x here. Finally, all that you are left with is a 1 upon x term, which is right here, into 1 upon that entire root thing which you had here. Let me just write that again. The root thing that you had in the denominator over here, that was root over 6 plus x square. Keep in mind you were rationalizing with that term, so there was a plus in the middle, and in the end there was a root 6. This is the final expression left after rationalization and a little bit of simplification. Just put x equal to 0 to evaluate the final expression. So you will have 1 plus 0 divided by root over 6 plus 0 plus 0, that will be root 6 plus root 6. So the final evaluation of this expression becomes equal to 1 upon 2 root 6. Let's go ahead with the second question. In all these questions, the principle remains the same. Every time you see a root, go ahead with rationalization and you will keep getting your answers. So here we will be rationalizing with root over 2x plus 3 plus root over 4x minus 3. All you need to do is change the middle sign here. Do not change the sign here or here. Okay. Divided by the same expression, that is root over 2x plus 3 plus root over 4x minus 3. So that will make it limit of x tends to 3. In the numerator you have a minus b into a plus b. So that will become a square minus b square, which is 2x plus 3, minus, in the bracket it will be 4x minus 3. So when you open up the bracket, it is minus 4x plus 3. 3 plus 3 will be equal to 6. And 2x minus 4x will be equal to minus 2x. And when you pull out a minus 2 common, that becomes minus 2 into x minus 3. In the denominator you have x square minus 9, which can be written as x plus 3 into x minus 3 into 1 upon their entire root expression is left over. This entire expression is left in the denominator. So if you cancel an x minus 3 term in the numerator and denominator, you will then be able to easily evaluate the limit by putting the value of x as 3 in the obtained expression. So you have minus 2 upon 3 plus 3, that is minus 2 upon 6, multiplied by 1 upon the entire expression which is there right here. So that will be root over 2 into x, that is 2 into 3, which is 6 plus 3, plus root over 4 into 3, which is equal to 12, minus 3. 6 plus 3 will be 9, the root of which will be 3. 12 minus 3 will be 9, the root of which will again be equal to 3. And 3 plus 3 in the denominator will make it 6. So we have 2 by 6 into 1 by 6. 2 gets cancelled here. We have minus 1 upon 3 into 1 upon 6, and the final expression, the final value for this expression turns out to be equal to minus 1 upon 18. Go ahead with the third question. Again, like we have done in the previous questions, all you need to do is rationalize this. So root 1 minus y square plus root 1 plus y square. The whole thing divided by the same very expression. So in the numerator you have a plus b into a minus b. So that will make it a square minus b square. So if you open up the brackets, it will be 1 minus y square minus 1 minus y square. the whole divided by, you have a y square, and then there is this entire root expression which you had in the denominator right here. So 1 minus 1 makes it 0, and we had minus y square, right? Yeah, so minus y square makes it minus 2y square in the numerator. Y square gets cancelled, and all you need to do is put y equal to 0 in the leftover expression to evaluate the final answer. So this will be minus 2 upon the final expression contained this term in the denominator, which is basically this term. So when you put a y equal to 0 there, you get a root over 1 minus 0 plus root over 1 minus 0. That will be equal to minus 2 upon 1 plus 1, and that will be equal to minus 1. So the final value for the third expression is equal to minus 1. Let's go ahead with the fourth one. Again you need to rationalize, but this time you need to rationalize the denominator as well as the numerator. So it will be root over 2 plus x plus root over 6 minus x, same term in the denominator. Multiply that further with the rationalization part of this, that is root x plus root 2 divided by root x plus root 2. Okay, so in the numerator this term and this term is getting combined. So in the numerator you will have limit of x tends to 2, a square minus b square, that will be 2 plus x, minus 6 minus x is in the bracket. So if you open up the bracket, it would be minus 6 plus x plus x will be equal to 2x, and 2 minus 6 will be equal to minus 4. So we have 2x minus 4. You can pull out a 2 common, so that will give you 2 into x minus 2. Now check the denominator. Root x minus root 2 into root x plus root 2 get combined. So that will give you x minus 2 in the denominator. That's not all. You have certain terms left in the numerator and denominator. This term stays in the numerator. So root x plus root 2 stays in the numerator, divided by this entire term stays in the denominator. So in the denominator you have root over 2 plus x plus root over 6 minus x. Now x minus 2 gets cancelled in the numerator and denominator. You can just put the value of x as 2 to evaluate the final answer. So that will give you 2 into, if you put x as 2, this becomes root 2 plus root 2 in the numerator, divided by 2 plus 2 will be 4 and root over 4 will be 2. So this is 2. 6 minus 2 will be 4 and root over 4 will be 2. So in the denominator we have 2 plus 2, which is equal to 4. Okay, 2 gets cancelled with the 4 here. So you have a 2 in the denominator. Root 2 plus root 2 will be equal to 2 root 2. 2 gets cancelled in the numerator and denominator, and the final value for this expression will be equal to root 2. That is how we are solving the fourth question. Let's go ahead with the first question of the second main question. Again we have to rationalize, and the rationalization will be done twice. So in the numerator that will be root over a plus 2x plus root over 3x divided by root over a plus 2x plus root over 3x. Multiply with the conjugate of the denominator as well, that is root over 3a plus x plus 2 root x, root over 3a plus x plus 2 root x. Okay, let's go a little quick with this. Limit of x tends to a. In the numerator, if you combine the terms, it will be a plus 2x minus 3x. In the denominator, it will be 3a plus x minus the square of 2 root x. That will be 4x. Because you have combined this term in the numerator and this term in the denominator, you are left with root over 3a plus x plus 2 root x in the numerator, and in the denominator you are left with root over a plus 2x plus root over 3x. If we simplify this, this will be a minus x, or this will be 3a minus 3x. So we can pull out a 3 common. We will have 3 into a minus x. Now a minus x can get cancelled in the numerator and denominator, and when we put the value of x as a in the expression right here, we will be left with 1 upon 3 into root over 3a plus a, that will be root over 4a, and that gives you 2 root a, plus the second term is also 2 root a only, I mean, it was 2 root x, but you're putting x as a. And here we will have root over a plus 2a, that is root over 3a. So that's like, okay, no, it's root over 3a only, plus root over 3a. So that becomes 2 times root over 3a. In the numerator, it is 4 times root a. You can cancel off a root a here and here. You can cancel off the 2 here as well as here. And the final value for the given expression turns out to be 2 upon 3 root 3. Okay, that's how we are solving the first question. We go ahead with the second question now. You can factorize the numerator and write it as x plus 2 into x minus 2. And after rationalizing the denominator, that denominator will become x plus 2 minus 3x minus 2. And the leftover part after rationalization will be left in the numerator. So that will be root over x plus 2 plus root over 3x plus 2, and that's what you have in the numerator. Okay, I've done it a little quickly because I believe that by now you have got enough practice of this method and you can calculate these things orally as well. I mean, at least you can make out which term is going where. If I open up the bracket, it would be x plus 2 minus 3x, and minus of minus 2 makes it plus 2. 2 plus 2 makes it 4 here, so plus 4. X minus 3x is minus 2x. Pull out a minus 2 common, so that will give you minus 2 and x minus 2. You can cancel off x minus 2 in the numerator and denominator, and x was tending to 2, right? So you can just substitute x as 2. So you will have 2 plus 2, which is 4 in the numerator, upon minus 2 into, substitute x as 2 here. So that will give you 2 plus 2, that is root 4, which is equal to 2, plus 3 into 2 will be 6, 6 plus 2 will be 8, and I'm so sorry, there's a 3x minus 2 here. Yeah, so that will be 3 into 2, 6, minus 2, that is 4, and root 4 will again be equal to 2. So 2 plus 2 giving you 4, 2 and 4 get cancelled giving you 8, I'm so sorry, 2 and 4 get cancelled giving you 2. The final answer will be equal to minus 8. So the final evaluation of that expression turns out to be minus 8. And with that we go ahead with our third question. So rationalize it by multiplying it with root over 1 plus root over 2 plus x plus root 3 divided by the same very expression. So that will give you limit of x tends to 2. In the numerator it will be a square minus b square. So that will give you 1 plus root over 2 plus x minus 3 divided by x minus 2 into root over 1 plus root over 2 plus x plus root 3. Now 1 minus 3 is giving you a minus 2, and we need to rationalize this once again by multiplying it with root over 2 plus x plus 2 upon root over 2 plus x plus 2. So when you do that, the numerator becomes a minus b into a plus b, which is a square minus b square. So that becomes 2 plus x minus the square of 2, which is 4. So we have 2 minus 4 giving us x minus 2 here, and that x minus 2 gets cancelled in the numerator and denominator. Finally, we will put x equal to 2 to evaluate the final answer. 2 plus 2 will give us a root 4 here. That root 4 will be equal to 2, and 1 plus 2 will be equal to root 3. So we have 1 upon root 3 plus root 3, that is 1 upon 2 root 3 as the value of this entire expression. Multiply that further with 1 upon this expression, that is, when you put x as 2, that will be 2 plus 2, which is 4, root 4 will be 2, and 2 plus 2 will be 4 again. So 1 upon 4 and the 2 here gets multiplied giving you 8. So 1 upon 8 root 3 is the final value for the third expression. Let's go ahead with the fourth one. Again rationalize this because you see a root in the numerator. So we multiply with root over a plus y plus root a upon root over a plus y plus root a. So this becomes limit of y tending to 0. And when you multiply the two terms, that will be a square, that is a plus y, minus b square, that is minus a, divided by y, root over a plus y, and in the bracket it will be root over a plus y plus root a. So a minus a gets cancelled. You can cancel off this y and y in the numerator and denominator. And finally, when you put y equal to 0 to evaluate the full expression, you will have 1 upon root a plus y will be root a. Root a plus y will be root a. Root a plus root a will be 2 root a. So the final answer is 1 upon 2a, because root a into root a will be equal to a. So 1 upon 2 root a is the value of the fourth expression. Moving on with the fifth one. Again, if you just rationalize this, you will have to rationalize it with the numerator as well as denominator. And if I just skip a few steps, then you should realize that in the numerator it will be x square plus 9 minus of 2x square plus 9. In the denominator it will be 3x square plus 4 minus 2x square plus 4. The rationalized part of the numerator term got combined in the numerator. So the leftover part of the numerator is what you will see in the denominator. So in the denominator it will be root over x square plus 9 plus root over 2x square plus 9. And in the numerator you will have the leftover part of the denominator. So that will be root over 3x square plus 4 plus root over 2x square plus 4. Okay, so in the numerator when you open the bracket, this will be a minus 9 here. X square minus 2x square will be minus x square. Plus 9 minus 9 get cancelled. So we have minus x square in the numerator. Open up the bracket here. This will give you a minus 4 here, and there's an x square term here. 3x square minus 2x square will be x square. 4 and minus 4 get cancelled. So again, when you cancel off x square in the numerator and denominator, okay, there is an x square left over here. Cancel off that x square in the numerator and denominator, and finally put x equal to 0 in the leftover expression to get the final answer. Okay, so that will give us minus 1, which was left over here, into putting x as 0 here will give us a root 4, and that value will be equal to 2, plus putting x as 0 gives us a root 4, which will be again equal to 2. In the denominator it would be root 9, which is 3, plus another root 9, which is 3 again. So we have minus of 4 divided by 6, that is minus of 2 divided by 3, and that's the value of the fifth expression. Let's go ahead with the first question in main question number 3. Now this first question is a little tricky question, but if you have identified the method there, or if you have identified the step there, you are easily in a position to solve that question. So all you need to do is add and subtract a 1. Write the numerator as x square minus 1 plus x root x minus 2 plus 1 upon x minus 1. So what I have done is I have subtracted and added a 1 in that expression. X square minus 1, keep it as one single term. Minus 2 plus 1 will be minus 1. Now think of this as one term, think of this as the other term, and split the denominator. So you have x square minus 1 upon x minus 1 and x root x minus 1 upon x minus 1. If you realize these two terms are of the type, these two terms are actually resembling the result. Limit of x tends to a, x power n minus a power n upon x minus a, and that value will be n into a power n minus 1. X root x, if you realize, x into root x is basically x power half. So x into x power half, that is like x power 1 plus half, and that will be x power 3 by 2. So I am writing that x root x as x power 3 by 2. You can think of this one also as 1 power 3 by 2. And finally, when you see the two expressions here, that is this expression and this expression, they resemble expressions of this type. So their evaluation can be done by that very formula, and you can say that the first expression, this, the value for it will be n into a power n minus 1, plus for the second expression the value will be n into a power n minus 1. So 1 power anything will be 1 only. So the final answer is 2 plus 3 by 2. That will be equal to 4 plus 3, which is 7 divided by 2. And that is the value of the expression that you have. That's the value of the given expression. Go ahead with the second one. Again, you need to rationalize it 2 times. So into root over 1 plus x square plus root over 1 plus x. Same term in the denominator, into root over 1 plus x cube plus root over 1 plus x, and again the same term in the denominator. So when you club these terms, it will be limit of x tending to 0. The numerator will become a square minus b square. That will give you 1 plus x square minus, second term is always to be written in brackets, okay? So when you open the bracket, it will be minus 1 minus x. 1 minus 1 gets cancelled, x square minus x is left over with you. You can pull out an x common to get x into x minus 1 in the numerator. Then this and this. So when you rationalize it, the denominator becomes this square minus this square. That will be 1 plus x cube minus bracket 1 plus x. You open up the bracket, it is minus 1 minus x. 1 minus 1 gets cancelled. X cube minus x. So you can pull out x common from there. So you have x into x square minus 1. X square minus 1 will be written as x plus 1 into x minus 1. Multiplied by, you will be left with two more terms. In the numerator, you had clubbed this term with this. So you are left with this term, which is root over 1 plus x cube plus root over 1 plus x. And in the denominator, you had clubbed this term with this term. So you are left with this term in the denominator, which is root over 1 plus x square plus root over 1 plus x. All you need to do is cancel this x here, this x minus 1 here, and put x equal to 0 in the leftover expression to calculate the final value of the given question. So it will be 1 upon 0 plus 1 giving you 1 multiplied by 0 plus 1, x cube will be 0, so 1 plus 0 and root 1 will be 1, plus similarly when you put x as 0 here, it will be root 1 which is 1. In the denominator it will also it will become 1 plus 1. So we will finally be having 2 upon 2, that is 1 as the final value of the second question. Let's go ahead with the third one. And again, okay, there's a root only in the denominator, but in the numerator you will at least have to go for a factorization. So in the numerator you can write that expression as x plus 5 into x minus 4. And after rationalization, the denominator will be a square minus b square. That will be 3x plus 4 minus 16. That is 3x minus 12. Take out a 3 common from the two terms. It will be 3 into x minus 4. But because you are rationalizing, there will be a term left in the numerator, and the leftover term in the numerator will be root over 3x plus 4 plus 4. And yeah, now you can finally cancel off x minus 4 in the numerator and denominator. Put the value of x as 4 in the final expression to get the value of the given expression. So you will have 4 plus 5 upon 3, which is like 9 upon 3. 9 upon 3 will be equal to 3 multiplied by, put that x as 4 here. You have 3 into 4, 12 plus 4, which will be equal to 16. Root 16 will be 4 and 4 plus 4 will be 8. So we have 3 into 8, that is equal to 24 as the final value of the given expression. Moving on with the fourth question. Again you need to rationalize it 2 times. So we multiply that with 3 plus root over 5 plus z divided by 3 plus root over 5 plus z, and multiply it further with 1 plus root over 5 minus z upon 1 plus root over 5 minus z. So the numerator will now become limit of z tends to 4. The numerator will be a square minus b square. So 9 minus 5 plus z. The denominator will also be a square minus b square, that is 1 minus 5 minus z into, you have clubbed this term in the numerator. So the numerator will have this term left with it, and the denominator will have this term left with it because you had combined this term with the term here. So in the numerator you are left with 1 plus root over 5 minus z, and in the denominator it is 3 plus root over 5 plus z. So the first bracket becomes 9 minus 5 minus z, that is 4 minus z, and the denominator is 1 minus 5 plus z. So this will be equal to minus 4 plus z. If you take out a minus common from the denominator, that will be minus of 4 minus z. So you can cancel off a 4 minus z in the numerator and denominator. So this will give you a minus 1 as the value of the first bracket. Substitute z as 4 in the second bracket. So you have 1 plus root over 5 minus 4, that is 1 plus root 1, which is equal to 1 plus 1. That is giving you a 2 in the numerator. Put that z as 4 here. So this becomes 9. This becomes root 9, which is equal to 3. 3 plus 3 becomes equal to 6. The final value is minus 1 upon 3. And that is the value of the fourth question. Let's take one last question in this video. So the value for this expression will be limit of x tends to 0. We just need to combine the two terms, okay? So we can actually pull out an x common from the two terms. So we have 1 upon x, 3 upon root 9 minus x, minus 1. Club the two terms. This will be 3 minus root over 9 minus x. The whole divided by root over 9 minus x. Rationalize it with 3 plus root over 9 minus x. So in the numerator it is a minus b into a plus b. And that will become a square minus b square. That is 3 square, which is 9, minus the square of root 9 minus x, which is 9 minus x only. Open up the bracket, so that will be 9 minus 9 plus x. 9 minus 9 getting cancelled, you are left with an x in the numerator, which gets cancelled with the x in your denominator. Now you can easily put x equal to 0 to evaluate the final answer. So this will be 1 upon root over 9 minus 0, that is root 9, which will be equal to 3, into 1 upon 9 minus 0 is 9, root 9 will be 3, 3 plus 3 will be equal to 6. So the final answer is 1 upon 18. That is the value of this expression will be 1 upon 18. So this is where I am done with the contents of this video, and do check out the other videos in this playlist so that you can get maximum benefits of whatever discussions I have done in this series of video. In this series where I am covering all the concepts of limits. And yeah, that's it. Thank you for watching. I hope that the contents were useful to you in your preparations.